So, you probably have never thought of cheerleading having physics. But how else would this girl get over in this whole flipping thing? Without physics, nothing is actually possible. Everyday life is physics. Whether you're just walking around, sitting in a chair, jumping on a trampoline, it's all physics, no matter how you look at it. The one thing is for cheer, there's jumping. Jumping is one of the biggest parts of cheer. The jumping uses a mixture of force, trajectory, velocity, and gravitational force. In this video, you're going to see, by bending her legs, she's preparing her force. And pulling her legs up, she's making trajectory in a parabola shape. Then she turns to speed up and higher her trajectory, the whole time she's fighting gravitational force. Getting up there takes lots of effort. Tumbling has more physics than jumping. When a cheerleader flips, she tucks her legs in, and this decreases the distance between the tumbler's body and axis of rotation. However, it gets complicated when they try to perfect it. A tumbler has to keep a constant angular momentum, and they have to be able to hit velocity and position equal to 0. This is not meaning you have to be going slower than the speed of light or slower than anything. This just means that you have to be able to stay in a straight line and straight speed the whole time, like so. As you see, she's going to stay along the same path. Whole time she's keeping a velocity and positioning that is technically equal to 0. Now, as we shift to stunting, I can show you a similarity between tumbling and stunting. Both use torque. They both pull in their bodies, just pull it in, twist to speed it up, let go, and they catch. Now, when a stunt starts, friction is used to prevent the flyer from falling. Bases use their legs and their arms to propel flyer up so she accelerates to a high point. When a flyer is cradled, the bases catch at a high point too. As she starts that extension, they cradle her, catch her at a high point, and absorb the force down. This lowers her trajectory and brings her down slower so she doesn't hurt herself. Okay, I have one more final thing to say. To prove my point that cheerleading has physics in it, I'm going to use Newton. Sir Isaac Newton. Sir Isaac Newton created 3 laws of physics that create a way for everyone who learned about physics to understand it better. Newton's first law of physics says that an object at rest remains at rest unless acted on by an unbalanced force. Also, an object in motion continues in motion with the same speed and direction of motion until acted upon by an unbalanced force. They hold her in a V, and she pushes her up and brings her up themselves. The flyer is unable to control whether they bring her up or not. Newton's second law of motion says that acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force is needed. Like when a cheerleader tumbles. Bigger cheerleaders that are taller and older have to use more force than little tumblers who just speed it through, because Newton's law, or third law of physics. For every action, there is an equal and opposite reaction. The action is the flyer pushing off her bases. The reaction is the bases pushing